Okay, here is a released free response question from the 2007 AP Chemistry exam. It's on acids and bases. They show hydrofluoric acid dissociating in water, and there it is there to form the hydronium ion and the fluoride ion with its low K sub A, which is the hallmark of the weak acid, hydrofluoric acid. They simply ask in part A for the equilibrium constant expression. Well, that's equal to the concentration of the products, H3O plus and F minus, divided by the reactants, which we'll only use HF for, since H2O is a liquid and is not considered to be part of the solution. Omit solids and liquids. It's about the only way you could mess that up. Use your square brackets for molar concentration, and that's one relatively easy point. They now want to know the molar concentration of H3O plus in a 0.4 molar solution. Well, once HF dissociates, it will form some water and some hydronium ion and some fluoride ion. We'll call those each X since they're going to be the same amount. So that's X here and that's X there. It was taken from the HF to begin with, and therefore we can call that 0.4 minus X. However, we're going to ignore that minus X since it's going to be much less than the 0.4 that we started with. We then solve that, and we end up with a value of X being 0.0017. That is that value there, as well as fluoride ion, but we need the H3O plus concentration, so it's 0.017 moles per liter. Now they're going to do a partial titration. They'll react it with some hydroxide, and specifically this many moles. Notice this is 0.015 liters of 0.4 moles per liter are added to more acid, right? 25 milliliters of the same concentration. So we should have 10 mils of the 0.4 molar. That's 0.01 liters times 0.4 moles per liter. And as you might guess, we get 0.004 moles of unreacted HF. It's just the moles of sodium hydroxide fully reacted, but we still have some HF remaining, and that's how much is remaining. They want the concentration of the fluoride in the solution. Well, here's what's happening. All fluoride is coming from the reaction with hydroxide. Therefore, the concentration of the hydroxide, or I should say really, the moles of hydroxide will be the same as the moles of fluoride. We calculated the moles of hydroxide up here, and there it is. That's the 0.006 moles of hydroxide. Since it all produced fluoride, it's the moles of fluoride, but they want molarity, so it's liters of solution, and we have two things in there, the 15 and the 25. So we have 0.04 liters of solution, and that's the concentration of fluoride. We're now nicely set up to figure out the pH of the solution because that would require a hydrogen ion concentration, which we can get from right there, where we have Ka, we now have the F minus, and we do have how many moles of HF are in that solution at that point, right? That's right there. And that's in the 40 milliliters, so using the same thing we did here, we can get the concentration of HF. So let's get all those numbers. There's the concentration of HF. We can plug into the Ka expression now, and the only thing we don't have is that, so let's rearrange to solve for it and plug in our numbers. And that shows us that the concentration of hydrogen ion is 4.8 times 10 to the minus 4. That's going to be a little stronger than pH of 4, and you simply take the negative log of the hydrogen ion concentration to get the pH, and it is 3.32. So that's the 2007 free response question on chemistry.